Okay, for your second assignment this week, it's about adding and subtracting rational expressions, but making a common denominator. So, the thing that I want to talk to you about, I want to just remind you a little bit about how we made common denominators back when you learned how to add fractions. So, what we did back in the day when we were adding something like 1/2 plus 3/5 is we decided what is the least common denominator of 2 and 5. In other words, what's the smallest number that we can build up 2, 2, and 5 to? And the common denominator of these would be 10. So what we would do is we would build this fraction up into something over 10, and we would build this fraction up into something over 10. And we looked, and that created that common denominator. So we looked to see how can we get from 2 to 10? How can we match up that denominator? Well, we would multiply it by 5. If I multiply the denominator by 5, I need to multiply the numerator by 5 as well, because remember, that was like we were multiplying by 1. So the equivalent to 1/2 is 5 out of 10. That makes sense, just thinking about it. And then if I look at this fraction to get from 5 to 10, I'd have to multiply by 2. So I multiply the numerator by 2, which meant I was multiplying the whole fraction by 2. Or I'm sorry, by 1. So 3 times 2 is 6. So again, 3/5 and 6/10. We know those are equivalent, right? We know 1/2 and 5/10 are equivalent. So we just created them into to what would make them equivalent. And then we followed the rule of when you add fractions, you write it over one denominator and you combine the numerators. Okay, and I know that's a improper fraction. Leave it alone. It's happy. It's fine. Don't do anything with that. So let's extend that into this sort of example with rational expressions. So I have our first problem, and the first two problems of Delta Math are sort of like this one. So what I'm going to do with this problem is to find the common denominator. What I know is I have a variable here and I have a family here. Remember that idea that I talked to you about when you have an expression, think about it as a group or a family. And if I needed a common denominator of a variable and a family, it would be these two things multiplied together. Okay, because common denominators are going to have a number part, they're going to have a variable part, and there's going to be a family part. And the number part, we're going to find a lot like we did for our first example, just from our back in the day. Remember the common denominator of these two, the number part was 10. So we're going to kind of throw all of this together in another video, probably something next week. But for right now, we're going to deal with families and variables and how we pull that together in a common denominator. So I don't have a number part here, but I do have a variable part of my common denominator. So I'm going to rewrite this over, x and x. That's the variable part of my common denominator. That's this one. And then I also need a family for both of them. X minus 1, x minus 1. I'm going to write more now than we eventually have to, but I want you to see that it kind of connects to what we did before back in the day. So if I look at this expression, I need to build it up to that denominator. What is it missing? It's missing an x minus 1. So see, if I multiply this x times x minus 1, this denominator matches that denominator. But according to the rule, I then need to multiply the numerator by x minus 1, by that family, because I'm multiplying this by 1. So that would make this numerator 2x minus 2. Now let's look at this denominator. We need to match it up or build it up to that one. So what I'm missing here is I'm missing an x. If I multiply the denominator by an x, I need to multiply the numerator by an x, and I get 3x. Okay, so what we've done is we have just created equivalent fractions. 2 over x is equivalent to this, and 3 over x minus 1 is equivalent to this. We built them up so they had a common denominator. And now remember what the rule says. Leave this factored, x times x minus 1, but write the common denominator once, and let's simplify or add together the numerators. I would get 5x minus 2. Also remember, just in case you feel like, oh, I would need to start to cancel, I really like this cancel stuff. This is a family. That is a family. Unless I can pull something out like an x or an x minus 1, nothing cancels. Leave it alone. That's my answer. Okay, let's do one more of these. And then I'm going to go to, probably have you go to Delta Math and do the first 2 examples, and then come back after and do the next 2. Watch the video of the next 2. Okay, so remember this idea. Common denominators have a number part, they have a variable part, they have a family part. None of them today are going to deal with the number part. We're going to pull it all together next week. But I do have a variable and I have a family, right? This is a family. So my common denominator is going to be the variable times the family. And I'm going to build this up to the variable times the family. Okay, so here's the process. Let's go over it again. To build this denominator up to this one, do you agree I'm missing an x? So I've got to multiply also the numerator by an x. That gives me a 2x squared right here. To get from this denominator to this denominator, I'm missing an x plus 2. That means I've got to multiply the numerator by the same thing because that will keep its value the same. And I will get a 2x plus 4. Okay, so now we have created our common denominators. So the next thing to do is to rewrite our fraction over one common denominator. And let's add the numerators. 2x squared plus 2x plus 4. Okay, I just want to think up to the side for a second before I decide whether or not I'm done. Because if in this family, do you see it? I have a family. That family right now is a trinomial. If I can bust out an x or an x plus 2, I could potentially cancel something up there. So let me look at let me look at just factoring this trinomial. And the first thing I see is a common factor of 2. So I'm just going to kind of think off to the side here. So I would have a 2 times an x squared plus x plus 2. And I really want to see, can I factor this trinomial? I don't know. Oh, nice. That mouse has been there the whole time. Sorry. So I'm going to try something. X times x gives me x squared. And 2, the only thing I can think of is 2 and 1, right? Because 2 times 1 gives me 2. But look what happens. If I multiply these two together, I get 1x. I multiply these two together and get 2x. The only way I could get a positive 1 right here is if this was a plus and this was a minus. But do you see that's not going to work because these two together, if I multiply them, would give me a negative 2, not a positive 2. So this numerator really does not factor, except we could potentially take the 2 out. But here's the deal. If nothing cancels, it's okay for you to write your answer this way. So this could be your final answer. If you decided to, though, you decided you wanted to write your numerator as this, 2 times x squared plus x plus 2 over x times x plus 2, because you wanted it to be as factored as possible, this would be okay as well. Or I would accept either one of them. If Delta Math gets weird when you guys are doing this and it only accepts one, please let me know. Because really technically I would accept either of them. They are both okay. The kind of math rule is, though, if it doesn't cancel anything, there's no reason to write the answer that way. And it's probably just a textbook rule. Okay, I'm going to stop this video and I want you to go to Delta Math. You're going to the problems, you're in Delta Math. And I want you to do the first 2 examples. They're of this type. Make sure you have your notes sitting in front of you.